class. Today we're going to be solving systems of equations by graphing. And before we get into that, I want to have a short review of graphing lines to make sure that everyone remembers how to graph a line. There's two forms of the line that you will most likely see. One form is this slope-intercept form, which you have a y by itself, and then you have the slope times x plus b, and b is always your y-intercept. The other form, which you will graph in a different manner, is the standard form, and for this you have some number times x plus some number times y equals some other number. Now, first thing you want to do is recognize, do I have slope-intercept form or do I have standard form, or can I manipulate the equation to make it into one of these forms? And then once you determine which form you have, you can determine the easiest method for graphing. We're going to start by reviewing this slope-intercept form. With the slope-intercept form, the b, which in this equation here happens to be 1, is your y-intercept. So if you look at this b, that's giving you a point on your line, which is 0b. And that's telling you where you're going to start finding your points for your graphing. So if we look at this particular equation, the b is 1, so that's telling me that I have a point of 0, 1. You can think of this as this is where you begin. So we're going to go to the graph over here on the right, and we're going to plot the point 0, 1, and always make sure you label your points. That's where we're going to start everything. Now, the slope is the number that's being multiplied by x right here. And if you'll remember, slope is rise over run. This is going to tell you how to move from your beginning point to the next point that's going to be on your line. If we look at this particular slope in this equation, it's a negative 2/3. So the rise is negative 2 and the run is 3. Since the rise is negative, that tells you you're going to go down from your beginning point. And if it was positive, you would go up. Since it's negative, we're going to go down. So we're going to go over to our point that's our starting point of 0, 1, and from there go down 1, 2. Then we're going to use our run of 3 to move forward 1, 2, 3. And right here is where another point on that line happens to land, and that point, if we label the coordinates, which you should always do, is the point 3, negative 1. Now if we want to find another point, we could continue from this point and go down 1, 2 more, and forward 1, 2, 3 more. And that ends up landing us right over here at the point 6. Oops, I'm running out of room there. I'll write it underneath. 6, negative 3. Once you get at least 2 to 3 points, you can go ahead and just connect those points to create your line as we did right here. And that is all there is to graphing when it's in slope-intercept form. You first find your beginning point, which in this case was 0, 1, and then you use your slope to move from that point to other points that you can label and then connect your points. Now let's look at standard form. When your equation is in this form, as our example right here of 4x plus 5y equals 20, it's easiest to graph it by using the x and y intercepts. And the x-intercept is when you cross this x-axis. When you cross the x-axis here, the y value is 0. So notice I've made a table and I've filled in a y value of 0. This particular point that we're going to label across this row is going to be our x-intercept. When you cross the y-axis, which is the y-intercept, you're crossing this axis right here. And on that line, the x is 0. So notice our other point here has a 0 filled in for the x, and this row here is going to represent our y-intercept. Now, the reason why we choose the x and y intercepts is because 0 is the easiest value to plug into a equation. It normally makes things just kind of disappear. So what we're going to do is start with this one here, and we're going to plug 0 in for this x right here, and we're going to see what we get. So we get 4 times 0 plus 5y equals 20. And 4 times 0 is just 0, so we can just make that disappear and then solve what's left over here. And what's left over here is 5y equals 20, so you can just divide both sides by 5, and y is 4. That allows us to fill in a 4 here, which gives us the point 0, 4 to plot on our graph. So we're going to go up here and plot the point 0, 4. Now, one thing that you might want to do when you're doing these x and y intercepts is you might have noticed that really, since this right here just disappears, you could have gone to this equation and just covered this term right here up with your finger and looked at what's left. And most people can solve what's left here in their head. You just divide the 20 by the 5 and you say y is 4. I call that my covering up method. You just take your finger and you cover up that and divide in order to solve what is remaining. Now, let's go ahead and find our x-intercept by plugging in our 0 for our y. We're going to replace this with 0, so we have 4x plus 5 times 0 equals 20. Again, 5 times 0 just cancels and disappears, and what's left is 4x equals 20. So we can divide both sides by 4, and x is 5. So we can fill a 5 in right here, and that gives us the point 5, 0. Again, you may have noticed we could have just covered this up with our finger and looked at what was left and gone ahead and divided this by 4 and that by 4 to get our 5 also. Now let's plot our second point. It's over here at 5, 0. You really only need 2 points in order to determine where a line goes. It's fine to choose any other x you would like to plug into this and solve in order to find a third point. The third point is nice as a checkpoint just to make sure your first 2 points are in the right spot. But if you have 2 points, that's really going to determine where the line goes. You just want to make sure they're accurate. And there's your line. So that's the 2 different ways for graphing. Now let's see what a system of linear equations is and how we solve those by graphing. We'll need to recognize whether we're dealing with equations that are in slope-intercept form or standard form, because that will determine whether we're going to graph like we did in this example or graph like we did in this example. Now, when we're graphing, really all you're going to do is a system is 2 equations. You're going to graph them both on the same coordinate plane and see where they cross. Now, you need to keep in mind one of 3 things will happen. And so those 3 things you're going to have to recognize in order to know what kind of an answer you're going to get. So you may have a graph of a coordinate plane, and you may actually graph both lines, say a line like this and a line like that, and they end up crossing, like you see right here. If that happens, all you're going to want to do is read off what the point is for what they cross and give me the ordered pair x, y. However, there's 2 other situations that could happen. You could have your coordinate plane and you graph your first line and it lands here, and then you go to graph your second line and it lands right here, and you notice that they're parallel. If they're parallel, they're never ever going to touch, which means you'll never have a spot where they cross, and what we're looking for in these problems is where did the 2 lines cross. So if something like this happens, your answer is no solutions. Now, the other situation that may happen is you may have a coordinate plane. We're going to put it over here. And you graph your first line, which I'll do in red, and it lands right here. Then you go to graph the second line, which I'll do in blue, and it lands right here. And you'll notice that both lines are in the same exact spot. When both lines are in the same exact spot, what that means is that the two equations were really the same line. They just may have looked different. Maybe one was in slope-intercept form and one was in standard form. But essentially, they're the same exact line. When that happens, your answer is that there's infinite solutions. And that's because every point that works in one line is going to also work in the other line. Now, when you're dealing with these, there are some fancy names for these kinds of answers, and you may or may not be required to give those types of answers. These types of situations here where you actually have a point for your answer are what we call independent. The type of situation over here where the lines were the same line and there's an infinite number of solutions, we call dependent. And then this other situation here where they're parallel, we also call independent, but they are inconsistent because they never cross. Now, a way to remember these particular situations, there's a little story some of my students actually came up with that you might enjoy. This situation right here where the two lines are independent, you can think of as two people had a blind date, they didn't like each other, so they went their separate ways. And so they're independent of each other for the rest of their life. Over here, you have two people that met, fell in love, and were married forever. So they were dependent on each other for the rest of their life. And then the other situation, which is inconsistent, is the two people that never ever crossed paths, never met, so they don't even know if they like each other. So that's one little story that might help you remember these things that my students made up, and they kind of enjoyed them. So now let's take a look at a system of equations and how we are going to go about solving them. We're going to first do a system where we have the two equations. Y equals 1/3 x minus 2. And then the other equation is going to be y equals negative 2/3 x plus 1. Okay, now for this first situation, actually let's get a coordinate plane on here and then we'll go ahead and graph it. We want to go ahead and graph the first one, and then we're going to graph the second one, and then we're going to read off the coordinate plane as to where they actually cross. Now, keep in mind that since we don't have graph paper on here, that we may have a little bit of human error. It's very important to have graph paper when you do these particular problems because it's very easy to make a mistake. You can use the slope, since these are both in slope-intercept form, to try and make yourself a little bit more accurate, but you'll want to be very careful when you're on a coordinate plane with your two equations to make sure that they're very accurate. Graphing is actually not the most preferred method of doing these equations because there's the higher probability of some human error when you're putting them on the coordinate plane. These are both in slope-intercept form because they both have y by themselves. So we're going to be graphing both of them using the methods that we use for slope-intercept form equations. Now, your system will typically have two equations. Often you see a set bracket off to the side. Not always, but some books you will see that. What we're going to do is I'm going to color code this so that this first equation is going to be graphed over on our coordinate plane in blue. The second one is going to be red, and that's just so that you can keep them separated and know which one is which. It's very important to completely graph the first one and have it on your coordinate plane before you ever even look at the second one. So on this first one, I first notice that my b is -2. That means that I have a starting point where I'm going to begin of 0, -2. So let's plot that on our coordinate plane. This is 0, -2. Now, we're going to use our slope, which is right here, in order to find another point so that we can connect it with our first point and see where our line goes. And the rise here is 1 and the run is 3. That means we're going to go up 1 and forward 3. So let's go to our starting point where we're going to begin at 0, -2 and go up 1 and over 1, 2, 3. We land right here, which is the point 3, 1. So let's go ahead and label our point 3, -1, because that's 3, -1. Now, it's nice to have a third point just to check and make sure that everything's lined up. So we're going to go from here up 1 more and forward 1, 2, 3 more. And we land right here, which is at the point 6, 0. We can now connect those and we get our line. And notice I completely finished off the blue one before I've even looked at my one that I'm going to do in red. The blue one is now on the graph and completely done. So looking at our red one, we have a +1 here. That means our beginning point is going to be 0, 1. So let's go ahead and plot that as 0, 1, like that. Now if we look at our slope here, our rise is -2. So we're going to go down 2, and our run is 3, so we're going to go forward 3. So we're going to start at our beginning one spot and go down 1, 2, and forward 1, 2, 3, and we land right there. And that is the point 3, -1. I can find another point by going down 1, 2 more and forward 1, 2, 3 more, and I land right here at the point 6, -3. Connecting those, I get a picture of my red line, and notice that they cross each other at this point 3, -1. So that is going to be the solution to our system, and we will say that the solution is 3, -1. Now, because there's so much error in graphing, one thing to keep in mind when you're doing systems by graphing is that it's very important to check your answer in order to make sure that it's correct, just in case you had some error in your graphing. So we're going to go ahead and do the check. If your directions say, is the point a solution to the system, the check is all that the problem's asking you to do. Let's do our check right here. When you're checking your point, which in this case is 3, -1, you essentially just plug it into both equations to see if it works. So we're going to start with y equals 1/3 x minus 2. We're going to plug in the -1 for the y and the 3 for the x and see what happens. So first thing I notice is these 3's cancel. So this turns into -1 equals 1 minus 2, or -1 equals -1. And that checks out and is true, so it does work in the first equation. Let's go to our second equation of y equals -2/3 x plus 1. Replacing the y with -1 and the x with 3, we can calculate. The 3's here cancel. And so we end up with -1 equals -2 plus 1. which means -1 equals -1. And that also checks out, so we know that the solution we came up with is correct. Let's do one more of these and see what happens. Our next system is going to be y equals -4/5 x plus 4. And the other equation is going to be 4x plus 5y equals 20. Now, we first are going to make a coordinate plane over here and label it. We have our y-axis and our x-axis, and we'll put some values on here so we know our scale. Now, I'm going to again color code this. This one will be in blue and this one will be in red. If we first look at our blue one here, it's in slope-intercept form, so we can graph it the same way we graphed the problems in the last example. So, this 4 is our y-intercept, which is going to be 0, 4. So we're going to go ahead and plot that right here as 0, 4. Then this slope here is telling us how to move from the starting point to the next point. And our rise is -4, so we're going to go down 4. And our run is 5, so we're going to go forward 5. So starting here, we're going to go down 1, 2, 3, 4, and then forward 1, 2, 3, 4, 5. And we get a point right there. And that point happens to be the point 5, 0. Now we can actually just go ahead and connect those. And we have our line. Let's go to the red one. Now the red one, I notice, is in standard form. So I'm going to need to use my x and y intercepts. So let's make a table for recording these in. I'm going to first plug in 0 for x, and then I'm going to plug in 0 for y and get 2 points that will help me find where this line is located. So first, plugging in 0 for x, notice that the x term disappears, and I have 5y equals 20. So I'm going to go ahead and divide both sides by 5, and y is 4. So now I have the point 0, 4. So I'm going to locate that up here and label it. Notice that I'm completely ignoring the blue one while I'm doing the red one. You'll want to do that so that you don't get the two confused. Now, I'm going to go ahead and take a look at plugging in 0 for the y. That gives me 4x plus 5 times 0 equals 20. Notice that this disappears. I divide both sides by 4, and x ends up being 5. So that gives me the point 5, 0. And then I'm going to go ahead and plot that right here and connect the two red ones, and notice that the red one and the blue one are in the same exact spot. That means that these two equations were really the same line, they just look different. One was in slope-intercept form and one was in standard form. That means that we have infinite solutions. And that is how you go about solving systems of equations by graphing.